Welcome back, my friends. In today's video I want to show you 3 easy ways how you can make your Shiny app faster or make it feel faster to the user. So with that said, let's dive in. For the first set of tips, I've brought you a little dummy app that I've built in a previous video. Here, really all you have to do inside of this app is to provide a name and then some months, and then you'll see that, okay, it displays the name that you've provided and it also tells you which months you selected. Now notice as I type something that the app immediately reacts, but this can be kind of bottleneck for your app. If you have some more complicated calculation than what we have here, then if your app reacts to every change here, then things might get queued and your Shiny app will be busy running all of the changes that you put in there. For example, let's simulate this harder or longer calculation by putting in a sys.sleep in here to see how this feels to the user. So let's put in my name in here, let's select the month, and now you see that it doesn't immediately show the text, but as I click on something, it tries to calculate a new version of the text that is displayed here, and as I click on more stuff and multiple stuffs here, then you see that things are queued up and your app is really busy for a long time to recalculate all the intermediate steps that you put in there. This can feel really bad for your user, so you want to avoid that. Instead, what you could do is to put your render function into a debounce function, which allows you to tell your app to not react immediately. Instead, we can say that it should react only after 1000 milliseconds. So if we now re-execute this, put in a name and then put in a month, then we have to wait a few seconds for the first iteration to come in. And now as I select stuff, we don't see that it immediately starts to blink to calculate new stuff. It waits a bit. Maybe waiting a second is a bit too long, but you could play around with these values here to make things feel nicer. What you could do instead, which is actually what I prefer to do, is to bind this calculation to this button that we have here. We don't actually have any use for this button yet, but what we could do instead is to bind this render call to the event that our button was clicked, and the button has this ID here. So now if I put in my name and select months, then nothing changes until I hit calculate. And now if a user tries to select multiple things and then thinks for a second and then selects another month as well, then still nothing has happened here because we haven't clicked the button yet. So now you see that things are recalculating. So that's one way to avoid overloading your Shiny app with lots of consecutive calls to the same calculation basically. But still, in the first iteration of this, if I put something in here and then select a month and then hit calculate, the user doesn't see that anything is happening until this output shows up. Later on, when the output was displayed once, then we see that this thing starts to blink once I hit the calculate button, so the user knows that something is happening. But it might be nicer for your user if there is a more obvious way to see that things are changing. And for that, the ATHLYTICZ package has a really neat action button that we can use instead of the regular action button. Namely, if we look into the ATHLYTICZ package and use the input task button, we don't have to change anything else inside of our app. We don't have to change the logic inside of the UI or inside of the server. We can just take this as a drop-in replacement. And now we see that the button looks a bit different. And if we put in stuff here, we see now that this row has a kind of rotating button here, and the user sees more easily that you're currently calculating something that might take a second or two. So in a way, this doesn't actually improve the speed of your app, but it makes it more bearable for the user, which is always something good for the user experience. But there's also something nicer that you can do with this input task button. You can use asynchronous programming to calculate long-running things in the background while the user can still interact with your app. And in order to make this work, what you have to do is to create a new variable. Let's call it task calculate the string. And this kind of variable will be filled with a so-called extended task that we create using some function that always looks the same, namely it returns a future. This is something from asynchronous programming. Don't worry too much if you don't don't know how it works, you just need to understand the template, and then you just stick into this future your slow operation. So in our case, it will be this code here, but we know that this code will depend on two variables. So let's make sure that our task also depends on two variables, and then we can stick in our slow code. Inside of the epoxy call, we use these two variables that we've just put into our function, and then normally it would work just like you'd expect, but with glue and epoxy there is some weird thing going on with things it can access. So in this particular case, you have to tell the epoxy function that it can access these particular variables, but don't worry about this particular thing. The real idea here is always that you just use code that is slow running in here. It's just with epoxy you have to also tell it these are actually the variables that we have already provided before, but you need some extra hint, so here it is. Other functions won't need this extra hint. And now that you have that, you can just bind this task to our task button of the ID that we have provided up here, and then we can put in an observer that invokes this extended task as the button is clicked. So let's put in an observe function. Let's bind it to this same button click, and then let's put in the same requirements that we originally had in here, and then say that we want to call this one, or rather we want to invoke it using the inputs that we have here. And then inside of our render print function, we can just take our task and say, okay, here we want to only get the result. And in this case, we don't actually need the bind event thing anymore because it only updates when this task was updated, and this one is already bound to this button event. So let's check out how our app feels now. So let's put in a name, let's select the month, and now let's calculate stuff. Okay, we're getting an error here because it cannot find future, and that's because we didn't actually load the library future that is needed for this kind of asynchronous programming. So let's try this again. Put in a name, put in a month, and then calculate stuff. No warnings just yet. And now we see that stuff happen here. So this worked just like before, but the nice thing is that the moment this code here is called, right after this, the R console is already free to do something else. You can see this by throwing in a show notification function that says calculation started, check back later. So now we can recalculate this, put in a name, put in a month, and now as we calculate stuff, we see now that the notification doesn't show up immediately. And the reason why is because we haven't actually enabled multi-sessions yet, so that we cannot pass this slow calculation to one session and another session is then available for the rest of the app. So let's activate this by activating the plan, multi-session, and now once we've done that, then we can put in a name, put in months, and as we hit calculate, we see that our notification immediately shows up even though this stuff isn't finished yet. So with this asynchronous programming, you can offshoot a lot of heavy calculations into the background while your R console is busy doing other things that are needed for this or some other calculation later on. So that's a neat way to make your app feel way faster than it is, because things then are just calculated or processed asynchronously, and the user doesn't have to wait for every step to finish one after the other. Asynchronous programming is a heavy topic, but I felt like this is a good place to put in here so that you can already start to get a feeling for these advantages. If you want to learn more about asynchronous programming, feel free to let me know in the comments. If there's enough interest, I'm happy to create a video on that as well. Asynchronous programming is really hard. Let's talk about some easier options you can use to make your app faster. Let's talk about update functions. For that, I've brought you a new app that looks like this. And as you can see from the title of this app, it has to do with changing user interfaces dynamically. So here you can see two sliders, and as I click on this set to 5 button, we see that this slider is set to 5. And then you can see the exact same thing, but this slider is called slider with update. And then as you click on this, you see that it also is set to 5. So you might wonder, okay, what's the difference between these two things? If you've noticed, as I click on this stuff here, then things kind of pop immediately to the 5. But as I do this here, then things flicker for a second. Even if I don't move the slider to a different number, as I click on this, things flicker for a second. And this can feel really weird for the user, and also this can take up some time to calculate. And the reason why this thing flickers but this one doesn't is because here the user interface is calculated with a render UI function function, but here it is calculated with an update function. Let's check out the code for this. You can see here's our first row. It has an action button and a UI output. And this second row, this is this code here, it has another action button, but here it doesn't have an UI output, but just a regular slider input. And if you look into the server function, you see that, okay, for this first UI slider, this is the UI output, we have a render UI call that checks what is the current value of this set to 5 button. If it has been clicked once or more, we want to always display 5. If not, we want to show some different initial value. See, if I reload this, both of them start at 7. And then this slider input is returned. In contrast to that, this second set to 5 button is just bound as an event to some observer where some code is executed that just updates this slider input. There you just say, hey, take this slider input with this following ID and set it to this particular value. As you can see, this code here is kind of easier because you already can set in the default values inside of the UI. You don't have to do some weird if-else thing. And also it is faster because when you click this first button, then this whole code block is re-executed, which might take time depending on what you have in there. So this flicker might be even stronger and not just really short. But when you do this update slider input, then really in the user interface nothing happens until this update function is called, and there is no flicker because this whole user interface element isn't recalculated as a whole, but instead only the value is changed as if it were dragged to 5 manually. So in a nutshell, you can use update functions for a smoother experience for your users, and depending on what you do inside of this UI output, it will also feel faster because the user doesn't have to see this flicker going on for a long time as things are recalculated. So if possible, always opt for update functions. Now, one thing that happens often when a Shiny app is connected to some SQL database is that all the data from the database is downloaded to the Shiny app and then processed inside of R. That is often not a fast thing to do, so let's check out how we can do better. For this purpose, I've created a little script that connects to some Postgres database that I've set up for this purpose here. So if we connect to this database, we can read a table that is called flights. And as we download it, we see that it takes a bit and then we can access this data. And in here just is a table with 300,000 rows that has some column flight ID and a column called departure delays in minutes. This is something I've just generated using some random numbers, but now we can work with this. First, let's check out how long it takes to get the mean departure delay by summarizing this table. So let's run this code here that does nothing but the summarize call, but it tracks the time using this tick-tock functions here. So as I execute this, we see that I get a mean value of 10, and also it took us 0.013 seconds to calculate this. So the calculation is kind of really easy, but let's check out what happens if we first call this read table function and then summarize stuff. Let's see how long this takes. So now it took us almost 2 seconds to get the data and do the summary. While we know that the summary really could be calculated really fast, but we didn't just stick to the calculation. No, we also wanted to download all of the data first. But there is an easier way to do this, or a faster way. You could just let the database do these kind of calculations for you, and then you only have to download the calculated values, namely this little table that has just this one number in it. And for that, you can just use the db-getQuery function where you stick in some SQL code that tells the database what to calculate. And here the code is also really simple. It's just saying select the average of this column that you want to pick, name it as this average departure delay variable, and the data that you need for that is from this table that we access anyway. So now if we run this, then we see that it only took us 0.05 seconds. It was much faster than downloading all of the data and then summarizing the data. So now if we execute this whole thing in one go without the outputs, the mean outputs in between, we can compare these 3 numbers and we see that really it is much slower to download everything and then doing the summary. So when possible, try to offload the calculations to the database and then only download the summarized data. In a lot of cases, it's really just a simple SQL query. And if you need some very elaborate stuff and you don't know SQL that well, you can use something like dbplyr, which uses dplyr syntax, but converts it to SQL, runs it, and then passes the results to you. This is also something you could use, or you could ask ChatGPT to help you. The point here is just make sure that you use something SQL based when possible, and then download only the summarized data instead. If you're interested in learning more about SQL, you could check out my video about this. And if you want to learn more about dbplyr in particular, I haven't covered this in a video before yet, just let me know in the comments, and if there's enough interest, then I'll make a video on dbplyr as well. Fantastic, we've learned 3 techniques to make our Shiny apps better. The last one technically wasn't really about Shiny, but about how to handle databases. But I feel like it happens so frequently that a Shiny app is a dashboard and a dashboard is connected to some database that it makes sense to put this kind of content in here as well to make Shiny look better. Feel free to share in the comments what you use to avoid bottlenecks inside of your Shiny apps. I'm sure there are way more techniques that I could learn about. And also, if you want to learn more about SQL databases, feel free to check out this video here. And if you want to see some of my other Shiny videos, then check out this playlist right here. And now, with all of that said, I say thank you for watching, and I will see you next time.